Hello, my name is Greg Goodson and I'm a graduate of the OTC HVAC program. In this video we're going to discuss the principles of electricity and electrical generation as they pertain to the dental x-ray machine. This information is found at the beginning of Chapter 2 in your Radiology for the Dental Professional Handbook. Now the students should already be familiar from Chapter 1 with some of the principles of electricity as they pertain to the x-ray tube itself, and that would be the generation of an electron field at the cathode or filament of the tube and traveling to the tungsten target or the anode. The electrical principles we're going to deal with is mainly how the machine itself utilizes electricity. Now, to understand the flow of electricity, I use the example of water flowing through a pipe. If you look at just the water that's actually flowing through it and the quantity of, that would be equivalent in an electrical circuit to the amount of current or amperes in the circuit. The thing that would most closely relate to the voltage would be the pressure used to push the water, and that would actually determine the flow and how much flow there is. And voltage is measured in volts and amperage is measured in amps. That description only describes basically a direct current circuit like you would have from a battery where electricity flows from one terminal to the other. Modern electricity is generated using generators which actually produce alternating current, which current flows in one direction for a specified amount of time and then flows back in the other direction for a specified amount of time. In the United States, this takes place 60 times per second, so it is known as 60 cycles per second or 60 hertz. Now, to explain some of the concepts of how electricity is generated, we will look at a diagram here. Now, anytime you take a magnet and a magnetic field and you move a conductor or a wire through this field, then an electrical current is going to be generated through the wire. Now, modern generators almost resemble a motor in the fact that you have two coils of conductors or wire around a common conductor in the middle. Now when this motor spins and these coils go through the magnetic field that are placed opposite each other, then current is generated going both ways in the motor. As it comes closer to the positive pole, it generates a voltage, and it comes down to the negative pole, it generates a voltage. This is basically the principle behind alternating current. Now when we represent this on a graph, you will see that a shape is formed that represents a circle along a timeline. And I'll draw this out here real quick. Now when you're speaking about electrical generation on the graph here, as the generator starts out and the motor coil is the farthest away from the magnet, you are actually at 0 volts. But as the motor spins and the copper coils get closer to the magnet, the amount of voltage goes up until you reach what is the peak voltage. Now as the magnet, or the coil of wire actually moves away from the magnet again, your voltage approaches 0 one more time. As it swings in the other direction, the magnets that are put opposite of each other in the generator are actually aligned with north and south opposite of each other. So when the motor comes back around and swings by the next magnet, it actually generates a negative voltage going to that same peak voltage as you had with the positive side. Now this all takes place in 1/60th of a second. So each half of this generated wave, which we'll call wave now, is going to be 1/120th of a second. And let me refer to my notes here real quick. Now, the dental x-ray machine actually operates on 110 volts, 60 cycles per second. With the natural operation and the way that the electricity is generated, though, get this back where we can see it, the cathode and the anode are only going to have the correct polarity half of the time. With the filament actually needs to have a negative charge on it for it to build up enough electrons to send to the tungsten target. So during one half of the cycle, as this generates peak voltage, there are electrons generated from the filament that actually go over to the anode. As it swings back down to the negative, there's very little electron buildup on the filament, so there's no way to generate a beam. Since this is not desirable, the X-ray machine actually has circuitry that eliminates the negative part of the cycle. In a broader sense, what we end up with then is just the positive pulses. The negative half ends up missing, but you still have these positive pulses going along this. This is actually called self-rectification, where you're only using half of the signal. And since these pulses are every 1/120th of a second, and you only get a pulse each 1/60th of a second, all dental machines are set by the multiples of 60. So when you're controlling a machine and giving it half a second exposure or something like that, you're actually talking 30 pulses, 60 pulses, some multiple of 60. Now, some of the modern machines, the circuitry can actually take this negative swing in the electrical generation wave and turn it into another positive, which makes for almost a steady generation of X-rays coming out, and thus allows you to half the exposure time, even though the patient is getting the same amount of radiation. Now, some of the things that are important to your X-ray machine is the actual peak voltage, which is going to be called your KVP, and that stands for kilovolt peak. Now, your KVP, kilovolt, stands for nothing more than 1,000 volts. And your kilovolt peak is going to be the very top of the wave that it's going to use here. And most dental x-ray machines run between 60 kVp and 90 kVp, which would actually be between 60,000 and 90,000 volts. Now, they actually use very little current to generate the x-rays. Okay, now, when we look over, the only last thing I need to probably explain here out of this chapter would be some of the components that are actually used in the dental x-ray machine. The first component we want to talk about would be the transformer, and what the transformer does is, going back to the same principles we used in the generator to generate electricity, you can take electricity and run it through a coil of wire. And then a transformer is nothing more than another coil of wire that is brought into close enough proximity to the first one to induce or transfer a voltage from one coil into the next. And if we put way more coils of wire onto the secondary coil than we did the first, you will in essence raise the voltage by the same ratio of turns that you've put into the increase. So we can take 110 volt power out of the wall and actually get it up to the 90 kilovolts that's going to be used to run the dental x-ray machine. The same principle is also used to step down the voltage from 110 down to approximately 3 to 5 volts to run one of the control circuits for the tube itself. Now, there are also an auto transformer which can make subtle adjustments to the voltage, and the smaller transformer is actually used to change the amount of milliamps that is supplied to the dental x-ray machine. And this has to do with the quality of penetration and the clarity of the shots you were actually taking here. So basically, in finishing here, the terms that are most important that you really need to know out of this chapter is basically to have a simple understanding of how electricity is generated to make the actual sine wave that we went over, and that the fact that the x-ray machine only can utilize one direction of flow and blocks the other direction of flow. That way your x-rays are actually just being generated in pulses. Now, when we use the terms rectification, that was taking the negative away, and self-rectification refers to the fact that the dental x-ray tube can block the negative half, and then what's called full rectification is when we actually change that negative part of the sine wave back to a positive and had a steadier voltage where we could half the exposure time. The other terms we need to remember out of here were transformer, and step-up transformer and step-down transformer. And as I explained, a step-up transformer just does exactly that. It steps up the voltage to the higher voltages you need to generate the x-ray in the tube. And a step-down transformer takes the voltage way down so it can be used safely in control circuits. That actually should complete that part of the chapter for you. Your instructor will come up with more videos here in the future to cover the actual controls themselves, such as the timer and the control panel, and there will also be more discussion about how the x-rays themselves are generated and filtered and used. Thank you for your time.